Hi, this is Michael King. In this video, we're going to be talking about ex post stock returns, which is past stock returns. In Booth, Clear, and Ricada, this is sections 8.1, 8.2, 8.3, and we're going to be looking at only parts of these sections. In this chapter, we're going to be talking about the future and the past. When we talk about the past in finance, we talk about ex post, and we talk about both returns and risk using terms such as total return or standard deviation. And when it comes to returns, you calculate the average using arithmetic or geometric means. But we're also going to talk later about the future, which in finance is called ex ante. And that means we're going to look at expected returns and expected risk. This video is going to focus on ex post returns. So let's say you buy stock for $10 and sell it for $12. What is your return? You sell at 12 and buy at 10, you make $2 divided by your initial investment of $10, you make a handy return of 20%. Notice that this does not say anything about the time horizon or the holding period over which you made this return. In finance, we distinguish between ex post and ex ante. Ex post is what you can see after the fact or historical or realized, whereas ex ante is before the fact, which could be called expected or forecast. Why does this matter? The reason is that much of finance is about forecasting what is going to happen and setting up your investment portfolio for the future, whether it's buying a stock or constructing a portfolio. However, after time passes, you will find out that what you actually earned is called ex post, what was really realized. So the term that people typically use in finance for measuring your return for a stock is the total shareholder return, or TSR. In the textbook, this is called total return. And TSR, or total return, has two parts: the income you receive while holding a stock, as well as the capital gain or loss that you experience from the time you bought it until you sold it. So in the notation in the text, you buy at P0, you sell at P1, and during the period you receive dividends of cash flow, or CF1. And so TSR in the text is defined as P1 minus PB0 over P plus any cash flows you received over the initial price. So that would be the dividends, which is cash flow 1 over P. Notice that the 1 and the 0 can be confusing because they suggest one period or 1 year, but that is not the case. They simply mean where you sell and where you buy. The first part, known as the capital gain or loss, is called capital gain yield in the textbook. The second part is the dividends you received divided by the price is called income yield, may also be called the dividend yield. I prefer to see TSR written this way. It makes much more sense to show price sell versus minus price buy, and you add up all the dividends. Notice that it's plural because you'll be getting dividends in multiple periods, and together this makes up the TSR. So let's look at this again. What if you buy a stock at $10, sell at $12, and in that interim you also receive $2 in dividends? Well, you can see that it's 12 minus 10 over 10 is your capital gain. But you also receive that $2 over your initial investment at $10, which is your income yield or your dividend yield. So the numerator works out to be you made $4 divided by 10, your initial investment, you made a 40% return. And this is why many people, when looking at investing stocks, will often look to buy dividend paying stocks. In the textbook by Booth, Clear, and Ricada, they have these three formulas, 81, 82, 83. Notice that 81 is simply the dividend yield, which they call income yield. 82 is simply the capital gain or loss, which they call yield because it's divided by the initial price. And then finally, total return, which is those two parts added together, income yield plus capital gain yield. So just to recall, total return is the same as total shareholder return, and it's made up of two parts: the dividends you received, which is called income, and any capital gains or losses. Notice though that this is a nominal return, which means that it incorporates or includes inflation. Let's take a look at how companies report this. Here's Royal Bank of Canada's 2020 annual report. And as you can see, they report that over a 3-year period, the average return that the shareholder earned was 1% per year versus their peers of a minus 6%. But over a 5-year period, the average return was 9% versus their peers at 3%. And you can see their peers in the bottom here, some Canadian banks, US banks, and international banks. Notice that over a 3-year period, the returns were not great, which just highlights how stocks may not be a good investment in the short run. You have to have a longer term horizon so that you can overcome what's going to be called the variability or the standard deviation of returns, which we're going to term risk. There's two ways to average return, and they're going to be called arithmetic versus geometric mean, where mean means average. The arithmetic mean is also known as the simple average. You just add up all of the returns period by period and you divide by the number of periods. The geometric is the one that we've been using most in finance because it takes into account compounding or interest on interest, and it may also be called the compound annual growth rate. Notice that it is a function of the returns, and you have to find the root and subtract 1. This is simply going to be a time value money calculation. So let's look at an example of measuring arithmetic versus geometric mean. In this example, you buy a stock today for $1 and hold it for 5 periods, and at the end it's worth $1.23. As you can see, the total return from the time you buy until the time you sell is 23%. You made 23 cents on $1. What would be the arithmetic or the geometric mean? Well, the arithmetic mean is adding up the annual returns, up 20, down 8, down 6, up 14, up 4, and summing them together, you get 24%. With 5 observations, you divide by 5. The arithmetic mean or average is 4.8%. And you can see that it lies somewhere between the minus 8% and the plus 20%, the extremes of the distribution. Okay. What about the geometric mean? The geometric mean is actually the compound growth rate from $1 present value to $1.23 future value over 5 periods. Calculating that, you would find that the geometric mean is 4.2%, and notice that it is different than the arithmetic mean. Notice that when we calculate that geometric mean, we are using this formula, future value, present value, 1 plus k over n, and we're trying to estimate what k is, which is the geometric mean. This just goes to illustrate how we use these time value money tools over and over again. So let's take a look calculating arithmetic and geometric mean. Here's a series of stock returns going from $1 up to $1.154. Notice that I have a different set of annual returns. They go up, they go down. So if you were to sum the annual returns, adding those 5 numbers together, they would add up to 15.4%. You would divide them by 5 and get the simple average is 3.1, which you can see is somewhere in the middle between the negative return of minus 7.6% and the positive of 10.5. If you were to calculate the geometric mean, you would say, well, I started with $1, I ended with $1.15. Over 5 periods, what does that work out to be from present value to future value? Well, your rate would be 2.9% per year. Notice that the simple average and the geometric average are not the same. The formula for that geometric mean, you can see it here. It's the future value of present value formula. Still to come, typically when we talk about returns, we're always going to talk about risk, and we're going to talk about measuring risk using standard deviation. That's in the next video. And then in a moment, we're going to come back and we're going to look at ex ante, which means expected returns and risk.